Hi everyone, and welcome back to another video. Today we're going to continue talking about web scraping. So if you just came off the last video, then welcome back. That was pretty quickly, right? So as I said, last video I was going over what web scraping is, and I gave you a pretty quick overview. I told you all the motivation of how it's used everywhere, from whether you're doing price monitoring, market research, sentiment analysis, news monitoring for finance, even email marketing. There's so many things that web scraping is useful for. But ultimately for us, what we want and what a lot of these people want and why they use it is to get data. They want to get a lot of data. The more data, the better, because ultimately you can think of data as an ore. You want to get a huge amount of ore so then you can go ahead and mine that ore and get the little bit of gold that you have in there. And if you have a bunch of ore and it only gets you this much gold, the more ore you have, the more little pieces of gold, which means you're going to get a bigger stockpile of gold. And that gold is the data that you're looking for. So let's go get us some gold, shall we? So in today's video, I'm going to be showing you some examples of using APIs. Okay, so APIs stands for Application Program Interfaces, and they're going to be the nicer way of doing scraping. So if you remember, I listed a couple of different ways to do your scraping, whether that is going to be through an HTTP request or if it's going to be through a regular expression pattern matching. Parsing is going to be involved. Document object model parsing or other better different ways of doing it, right? So we're going to kind of start out easy, and we're going to get scraping from websites that actually are cool with it. And how do we know they're cool with it? Because they actually have a special system that is just made just for us, meaning that the website actually is like, okay, this is going to happen. I'm going to sell it to you. They can sell it to you. They can, if you want to scrape a little bit, it's free. You get the taste for free. But if you actually want a lot more, then you actually have to, they have to pay to make more calls. So every time that you make a call or a request, it's going to sort of be limited. So usually you have to create an account with them. You have to create an account with the company or website that you are trying to do the scraping from. And then they will give you some sort of special credentials, which we call like the API keys or API credentials. And then with these credentials, they are going to allow you to send special requests. And the requests typically look just like a website. So like imagine some URL link that's like HTTPS, in twitter.com/1235/458/NASA. Okay. And that Twitter request, while it just looks like a random website, it's not. It's actually a special request that is meant to send to Twitter a request asking for all the tweets from the NASA Twitter page, and then you get those back. So that is how we're going to count like +1 to your request count, and you might have a special limit, rate limited of like maybe 100 per day or 100 per hour, which might seem like a lot, and it is a lot if you're just doing a couple of quick things. But if you're trying to automate and you're trying to do like big data analysis stuff, then 100 is nothing. You're going to need like thousands upon thousands per day. And for that, you're going to have to pay Twitter some big bucks. And that's okay, because ultimately, you're doing this for a company that is probably going to make even bigger bucks from this, right? And if not, then why are you doing it in the first place? So you have to do cost analysis, right? Okay. So having said all of that, the reason why I said Twitter today is because we are going to be using Twitter for our first example that I have. So a couple of semesters ago, I was bored in the summer of, this was spring 2020, summer 2020. And I was bored, and I was creating some assignments for my students for programming in C++. And I said, wouldn't it be cool? You all took programming for data analytics 1, so you all know how to use classes in the basic sense and how you can use that class to store different data types of information, right? And so that was what they were practicing essentially. They were practicing, they call in C++, in that level, they're called structs, but they're also classes in C++. They just don't learn it in that step. And I was like, okay, instead of them just giving them the random data to organize and nicely print out to the screen, why don't I give them something cool like a bunch of Twitter data? And even better is, what if it's real Twitter data? And so what I said is, okay, let me go ahead and see if I can download just a bunch of Twitter data for a bunch of accounts and just give it to the students. And then they have, they give them motivation to do something interesting. And so that is how this project came to be. So what you're looking at here is the code for the project. But first, let me introduce to you to how I did this, okay? So I have a bunch of pages that I'm going to just go through. They're carefully curated websites that I went through. So the first thing is Tweetpie. Okay, so Twitter has an API, and the Twitter API, in fact, actually maybe I'll skip around this one. So Twitter has a developer platform, okay, and the developer platform is developer.twitter.com, and you can read all about it under the About section. So developer.twitter.com again, and as you see here, it says the Twitter API can be used to programmatically retrieve and analyze Twitter data, as well as build for the conversation on Twitter. Over the years, the Twitter API has grown by adding additional levels of access, etc., etc. And then you, of course, see the different levels. As you can see, just like I was talking about, certain levels are free, and certain levels are potentially priced, I suppose. Well, in this case, it says coming soon. So I guess they're not quite priced yet, but time. So in this case, we have different layers of access. So what this is saying is that you're able to request data from Twitter for free within a certain level. So in this case, you have your basic level, you have an elevated level, which is not for everybody. You have to request special access. And you also have the academic research side, which is the one that I have and I want you all to apply for. Well, I mean, actually, you can even go with essential. That's okay. Either or is fine, because we're only going to be using the basic API. There are limits on the number of projects you can have, the number of apps you can do, but more importantly, you can see here the caps. This is how many requests you can do per second. So you can see here things like 25 requests for every 15 minutes, 100 requests for every 15 minutes for the academic one, and the number of tweets you can do. So like a single request can contain multiple tweets. So you can say like, give me all the tweets from NASA. That's one request. And the number of tweets that NASA has could be like hundreds. But it could also be like a small account that only has 5 or 6. So this is saying you can do that many requests and there can be that many tweets back. This is just a limitation of how many tweets you can get. And so on. So these are the kind of things that you can see are going to be explained to you over an API. And then of course you can read documentation, etc., etc. But ultimately, this is how I get information from Twitter. Okay? So on that side, okay, cool. This is how I communicate with Twitter. So this is how I send a request to Twitter. But now I need the other side of the coin. And that is how I can communicate between Python and creating the request, and then I can send to Twitter through this API. So for that, I need some special code in Python to be able to generate the request in the formatting and syntax that they're requesting it, that you do it in. For that, we have Tweetpie. Tweetpie is, as it says there, an easy-to-use Python library for accessing the Twitter API. How do I find Tweetpie? Just Google Tweetpie, okay? So, Tweetpie. That itself has documentation. So a lot of the times these APIs, both the API will have documentation and then the library that is usually created to access the API on Python or other languages will have a documentation of its own. And it's great because it's going to give you examples. This is literally how I created this. I went through the documentation, looked at examples, copy-pasted some examples into my code, started modifying it until I finally created what I wanted. And that's probably the system that you should use. And the more you do it, the more comfortable you'll get doing this kind of thing. Okay? So you can see here, it's a very, very basic Hello Tweetpie example. So this is like the basic program, and we have a couple of lines. So let's actually go through some of these lines and understand what is happening. Introduction. If you're new to Tweetpie, this is the place to begin. All right, so as you can see, the first thing you need to do is you need to import Tweetpie. So Tweetpie is going to be a library. Now this library is not built in Python. You have to actually download and install it. So how do we do that? It's in the documentation, but I'm just going to go ahead and show you since I actually installed it in our class VM earlier today before the lecture. And all I have to use is pip. I can just use pip install Tweetpie and bam, it is installed. It took literally less than 5 seconds. It's a pretty small package. In fact, I saved the installation video or installation messages here. Does that have any timestamp? Nope, it does not have timestamp. But yeah, I did it pretty quickly, okay? Once that is installed, then I am ready to use it. If you don't install it and you try to run Tweetpie, it'll give you some kind of error. I think it just said like Tweetpie module not found. And that's I was like, oh, I guess I gotta install it, which is good because I can then take that picture, okay? But yeah, so once you have it installed, then you're able to run this line of code, import TweetPy, and it works. Then you have to understand a couple of things here. So we have this authentication TweetPy authentication handler, we have access token stuff, and then we have this API variable, and then now we have like actual code. So the first thing is, as I said, most APIs, not all of them. In fact, an example of that being the next one that I'm going to show you, which is going to be a blockchain one. But for now, I'm just going to show you this Twitter one. The blockchain one does not require a login at all. But the Twitter one does, because as you saw there's different tiers. The most basic one is just a basic login, but it's still a form of login because then they can track who's doing what and how many requests you are doing versus just like limiting to like an IP address or something. So for that, it's not like your normal login. Like you're not going to get a username and a password. It's going to be a little bit more complicated than that. In fact, it's going to look a little bit like this. So you're going to actually have to do that to the Twitter website. But what you're going to get back once you do it, it's going to be these 4 keys. It's going to be a consumer key, a consumer secret, an access key, and an access secret. Now, these are not my actual keys. I went ahead and changed it here so that you couldn't see them. Not that I, particularly care if you saw them, but then again, if people start using them and then I want to use them myself, then I won't be able to because you'll be maxing them out per day, something like that, right? So that's why I was like, I might as well change it. But if I encourage you all to please go and create your own keys. It's just a sign up process. It's going to take a little bit. It's not immediate though. When you request a sign up, it does take them like a day or two for them to actually process the request and then give you the keys back. But particularly in my case, when I applied for academic, because I had to submit to them proof that I was in school. By the way, it's not like I have to be a faculty. Any student can request it. You just have to prove, like I think it was like a student email, and has to, submit that, tell them that I was computer science, and then they got it. And so in the past, I've tried, I like having students sign up for this, and they had no issues with it. It's just it took them like 2 days, and this was pre-pandemic. So post-pandemic, actually no, that was not pre-pandemic. It was 2020. Yeah. So actually, so they should take that even in the current situation of pandemic. Okay. So once you get those, what this is doing is this is basically loading the passwords per se that you have, and then connecting to the Twitter API and basically doing that sign-in exchange. Okay. And once you're there, then this is just going to be a call to the actual Twitter API. In this specific case, what this one is doing is it's probably requesting all the tweets from your own homepage and downloading them. And now they're all downloaded in a list, or I don't know, this is probably not a list, it's probably like a special object, but for all intents and purposes, think of it like a list of tweets, which then you can just iterate through with a for loop and print them out. Okay? So very, very basic example to just take like your own tweets and download them. And look at this, it's what? 3, 6, 7 lines of code, and you have Twitter in your hands, like the world of Twitter. Well, at least your own Twitter, okay? But just how you did this, you can very similarly do something for any other Twitter page, not just your own. So this is cool. Like, think about the power. Like stop for a moment and think about the power that you have here. You're able to access any tweet from Twitter from any time period and download it. And not just one, but hundreds of thousands, or I guess millions in that case, probably. So you just think about the possibilities of the amount of data that you can get and the analysis that you can do. Like, I don't know about you, but that just makes me all excited all over again. And it should you too as well. That's how you know you're in the right field, right? So here's some example of documentation. I am not going to go over this documentation. I just wanted to show you that it's all available. It's very friendly. So you can do things like getting started. Authentication tutorial is how to actually request the authentications and how to make sure that it works. Code snippets, they give you some examples of things that you can do. API references will give you details on the actual API calls and what each thing does. And some things I'll go over in a minute here because I'm going to show you that full example. But yeah, there's tons of things you can do. Okay? So my goal right now is I want to get all of the tweets from the NASA page. Now, why the NASA page? Because I thought that's the safest page that I could get tweets from without getting something scary, right? Yeah. In the past, I did this with like Elon Musk's tweets and or previous president's tweets, and that one didn't turn out too well because we found some interesting stuff. But yeah, so this is the nicer, safer looking one. But you're welcome to try this on any Twitter account that is public. It has to be public though, because otherwise the Twitter thing will say, unless you have access to it, because you're permitted with your account, like your own, okay, so there's two requirements for this, I should say. You have to make a normal Twitter account first, and then request a developer account linked to your normal Twitter account. So if you have special access to special Twitter accounts, like if you have a friend whose Twitter account is usually private, but because you're friends with them and they let you follow them or whatever, then you can see it, then I guess technically through the API you could access it. But otherwise you cannot access things that are private. Okay? So let's go over the code and get some fun. You'll see here that I'm importing a couple of other things other than the TweetPy library. I'm importing CSV because at the end of the day, what I want this script to do is to download Twitter data into a CSV file, because I love CSV files. They're easy to process later on. I could just download the Twitter data directly to a local variable in Python and do my analytics, but then every time I run it, it has to re-download it again. And every time I'm going to use a special request, and I'm going to run up my rate. And I want to keep it as low as possible. So it's a good idea to download a copy of the data you want locally, and then you can do all you want in that local copy so that you're only requesting the least amount of times. And this doesn't just apply for this API scraping, but in general for scraping, the best approach is to download the data that you need and save it locally so that you do the least amount of requests possible to the server. If it's legal to do it, then it's just a good thing to do because you don't put as much load on the server. If it's illegal to do it, then the more times you do it, the higher the chances you're getting caught, because they're going to notice that you keep requesting a lot of information, and they're going to either block you by IP address, which is more than likely what will happen, and that'll be the end of it. But potentially they could find out who you are and prosecute you or something. But like I said, I'm not encouraging any of you to break the law or something, but I'm just telling you what seems to be the trend is, if you scrape data from someone doesn't want you to scrape data, they'll just block your IP address either temporarily or potentially permanently, and that'll be the end of it. Usually, at least on a non-business sort of hobbyist level. Okay, so please don't worry too much about that stuff. But again, I'm washing my hands here. If I'm not gonna bail you guys out of jail, okay? I like you guys, but yeah. It's a lot of money to bail people out of jail. So yeah, I'll send you a letter. I'll send you like I'll send you a chocolate cake with a file inside or something. No, but okay. The Unicode data, if I recall correctly, this is only because I want to process the text and I want to clean it up. I think, and this Unicode thing helped me out. We'll see it in a second. Don't worry too much about it. This is just me, my standard cleaning the screen so that I clean it here, but it's not really doing anything important. So ignore that. Okay, now I have a function called getAllTweets, which is where the real code happens, but I also have at the bottom a main function. So I'm going to start with that. The reason I made a main function in Python is because when you do a main function like this, you actually allow the computer to have the starting point of the script. And so you can use command line arguments. And command line arguments allow you to, when you execute a Python script, to say something like Python 02.py, and then put some text after that. And the way I set this up is that the text that you put after the name of the Python script is actually the name of the user, the Twitter account. In this case, I went in and edited and I just hard-coded for the NASA one. So, but normally, the way I originally had it, that's what happens. It literally asks me to execute this by saying Python 3. I guess the original name of the script was downloader.py, and then putting in the user that I actually want to download the tweets from. Okay, so all I'm doing is I'm saying this is the account that I want to get the tweets from. So like I said, all the fun happens in that function. So let's look at that function, okay? The first thing I do is I'm opening a text file that I have in the same directory, which contains my 4 credentials. So the text file looks like 4 lines of gibberish, each line being one of these keys or secrets. And then I made sure to do the strip part because I need to be able to remove the line feed. I guess a cleaner version of this would be to do something like this, to be able to remove just the line feed, just in case that the key had actual spaces in it, but I don't think that's a standard thing for a key to have, so I think this gets away with it. And so I have these 4 variables, but this is what they look like. And this is what you should get from the Twitter API website. Not from Tweetbot, but from Twitter itself. This is your credentials to log in, and they're exclusively for you, so don't share them with anyone else. It's like sharing your email password. Don't do that. Okay? So once you go ahead and got those keys and go ahead and load them in just as string variables, now comes in the authentication for Twitter. This is literally copy and pasting from the website that I showed you earlier. So this here, looks the same because it is the same. And this is basically just me authenticating to Twitter. So this is me logging into Twitter for this to actually work. Okay? So the rest of this is just me basically preparing to receive the information and receiving it in a nice way. And so what I'm doing is I'm going to create two lists, as you can see by the documentation here. Always document your code is good because, look at me. I wrote this at this point almost 2 years ago, but I can go back and understand it because I wrote documentation. Otherwise, I would be like, yeah, it works, and that's all I know. I hope it continues working, right? So you don't want to be in those situations. So that's why you should document your code for your own benefit, but also for the world if you need to share it. So in this case, I have a list that's going to hold all the TweetPie tweets and a list with no retweets, okay? So all tweets contains all the tweets I download, but I wanted to only get the tweets that are not retweets. So if you don't understand how Twitter works, don't feel bad. Let me just go over that. So Twitter, normally the way it works is there's two kinds of tweets. There is the normal tweets that are coming from the account, like just hey, this is me or whatever. Or in this case, it's talking about, I guess about the movie Moonfall. Wow, that's a moment. But yeah, so these three galaxies in Constellation Phoenix appear to be on a collision course. Okay. Yeah, very cool, NASA. All right, so those are the kind of tweets, but there's also retweets. Retweets are when NASA takes somebody else's tweet and reposts it, like this one right here. So in this case, they retweeted a tweet by the NASA Space Communication and Navigation website, which is, I guess, a subgroup of NASA. So they retweeted that post. So it shows up on the NASA website, on the NASA Twitter, but it's not written by NASA. They just reposted it because they wanted to share it with the world. So in the days of social media, your friend posts very deep words of the wise, or maybe they're talking about a campaign to help somebody that was in an accident or something. You go ahead and repost it to you, so you help to spread the information. That's the concept of reposting or retweeting in this case. Okay, so yeah, another example of that is this one from Women at NASA, right? So Women at NASA is a NASA website, which I suppose is promoting women in NASA, making history in NASA. And so they wrote a tweet about this woman. And so, NASA website, I probably would have seen this tweet if NASA hadn't posted it, because I'm not subscribed. Well, I don't use Twitter, but if I was, let's say I would not subscribe to Women at NASA, then I wouldn't have known it, right? So that's the whole idea with retweets, okay? But because I'm looking for strictly the tweets by NASA, just because that's what I'm looking for, then I want to go ahead and remove that. So I have two lists. So I have the whole thing I get from NASA, and then the cleaned up version, okay? So let's go ahead and request the tweets from NASA. So that's what this line is going to do. So make the initial request for more recent tweets with extended mode enabled to get the full tweets. Don't worry too much about the extended mode thing. You can read more about it. But basically, this right here is the request, okay? This is going to be the one time I communicate with the Twitter website for information in this script, if I recall correctly, okay? So this is saying, hi NASA, or sorry, hi Twitter. Please send me the timeline. So this is the page, the main page, for the screen name given. In this case, the screen name being NASA. That's why this is the parameter that you get passed in here, which is going to be NASA, as we saw from main. And then there's a couple of flags, which I'm saying, give me the extended mode. And I guess there is more than one request, because I am saying only give me 200 tweets here. So just give me the first 200 tweets. And the reason I do this is because if I request more than if I just say hey, give me all of the tweets from this page, and the page has a lot of tweets, I think it would reject my request and say there's too many to return. And so what I had to do was I had to only request X amount to make it work. So I think that's why I set count to 100. I'm just saying, give me the first 200 tweets, and then I'm going to go ahead and request the next 200 and so on. So that's why I have that parameter there. How do I know this is a parameter from this? Like, how do I know this is a thing? Well, API user timeline. That's where your documentation is going to come in, right? So somewhere in here, in the documentation for the API, there is a user timeline. Is it user.timeline or user underscore timeline? User underscore timeline. So I'm going to go ahead and just type it on the search bar. And not get the latest version. Okay, why? User. There we go. TweetPy. There we go. So this here is the user timeline. So this tells me all of the different things that I can feed it. And it also gives me a reference to the developer website from Twitter, which is like actually where that information is coming from. So overview. Important notice, we begin limiting the total GET requests. A timeline is simply a list or an aggregate stream of tweets. The Twitter API has several endpoints to return that. Okay? And you can see the different things I can request. Parameters, count, so there's my count, optional. Specifies the number of records to retrieve. Must be less than or equal to 200. See? So by default, you can only get up to 200, so that's probably why I put it. The default is 20, so meaning that if I try to not include this parameter, all I get is 20 tweets back. So that's why I did it. Yeah, there we go. If I don't put that in, I'm only going to get 20 tweets back. But I wanted to get the most I could. So I said, put it up to the limit. How do I know what the limit is? I must have read this documentation and saw that. Okay? So the value of the count is best taught as a limit of the number of tweets to return because suspended or deleted content is removed after the count has been applied. Okay? Other things that I could have put in here. Exclude replies. This parameter will prevent replies from appearing in the return timeline. In fact, what's the other thing I had in there? Oh, well, I had extended mode. Extended mode is probably somewhere in here. Well, here, control F. Extended. Ballot requests are compact and extended, which give compatibility mode and extended mode respectively. Oh, so extended mode is because some of the tweets nowadays, so apparently Twitter back in the day, you could only do 140 tweets, or sorry, 140 characters in the tweet. Then they made it so you could do longer tweets, and so extended mode allows you to actually get tweets that are longer than 140, otherwise I guess it cuts it off or some bad thing happens. Okay, so what does that query look like? Well, when you request the query to Twitter, what you get back from Twitter is a JSON. So what does a JSON look like? A JSON looks just like this. So this might look like weird, unreadable code. You're like, huh, this is some like matrix thing, but it's not. It's actually very simple to understand how JSONs work. JSONs, actually, JavaScript, object, what does JSON actually stand for? That's a good question. I've never read, I mean, I'm sure I knew that at some point, but I forgot. Let's see JSON. Oh, it's just, what is it? What does it actually stand for? JavaScript object notation. There we go. Yeah, so JavaScript object notation. Okay. So what it really means is that, actually, that is a good way of explaining it. It's an object. Hold on. I'm trying to look for it. Here we go. It's an object. So an object has basically different things in it. It's a class. Like think of classes in Python. So it has different variables inside of this big encapsulated item called an object. So for example, what kind of information it contains? Well, think of it like a record. So it has the created at time, so the time the tweet was created at. It has the text of the tweet. It could have things like links in the tweet. It can have, probably has the name of the Twitter account that did it, even though we know what it is because we requested it. It has a unique ID for the tweet probably. Amongst other things like how many times the tweet has been liked, how many times has it been retweeted, how many times has it been favorited. These are all things you can see on Twitter when you're looking at a tweet at the bottom of the tweet. So like replies is this one, retweets, favorites, and I think that's it. So you can see those kind of things there. So you get it all nicely organized as a response right there, so you can see it. And of course you get this per tweet. So it would be like a JSON made up of a bunch of these sort of sort of JSON objects in it. And the formatting is for JSON for now. All you need to know is that you start out with the curly brace. When you want to like give the key of the specific value, you put it in quotes, and then you put the key name. So in this case, it's the created app. You put a colon, and then you put a space, and then you put another set of quotes, and inside you put whatever the value is for that key. So created app, and then you put the date, comma. Next thing, ID, and it has the actual ID. When it comes to numbers, you can either put them with quotes or without quotes. If you put them without quotes, they're considered to be numbers. So that's why, in this case, Twitter has two versions of it, of the ID. It has a numerical ID, and it also has the ID as a string version. That's probably a thing to play it safe so you don't overflow if you're trying to read this into like an integer or something like that. This is the good one though, text. So this is our key. So it means this is text. And so how do I then process this in Python? You don't need to like parse this. Like that's actually parsing, the concept, because I mentioned parsing last time. Parsing would be taking this and actually feeding it into like actual Python object that contains the same fields as this. You don't need to do that. There's libraries that will do this for you automatically for any JSON object. You just have to make sure it's actually formatted correctly, which they probably are if it's coming from like Twitter. But the TweetPy library actually already does that for you, so you don't even need to worry about that later. Yeah, so at some point, if I were talking about my clinical trials project, in that case, I actually generate my own JSON, so I needed to use the JSON library. But it's called, like, I think it's just import JSON. I can't remember. I think that's the library name. So it's all very convenient. But yeah, so this is what the request looks like. This is what you're actually getting back from Twitter. I just saw that was cut up. I apologize for that. But yeah, looking at another one, like for example, friend count. That's kind of sad. This person only has 12 friends on Twitter. Well, actually, that's more than probably what I have, because I only made the Twitter account for like using this kind of stuff. So yeah, but like for example, favorites count. So this is how many times they got favorited, right? So this tells you what it is, 32. So then you can actually process it locally if that's something you do care about. Okay, so all this information that you get back, you probably don't want it all. So what you're going to do is you're going to only save the stuff that you want, and that's what we're going to save to our file, to our CSV. Okay, so there we go. After we get this back, we're going to get this new tweets that's going to contain a special object that contains all the 200 tweets and all the information basically that the JSON gives us for each of those tweets. Okay, so from there, what I'm trying to do is I'm going to append that to my empty list that I created called all tweets. I'm putting the new tweets there. So that's what this is doing. So I'm basically adding it to the list. I could have probably just put that there immediately, but that's okay. Sorry. Since I recorded the 2 lectures back to back, my throat's a little bit tired. But from there, let's see what else I do here. So save the ID of the oldest tweetless one. Don't worry about that. Error checking for small accounts. Don't worry too much about this. This is some error checking I do for edge cases of like things breaking if there's less than 200 tweets. Because ultimately what I want to do is I want to get 3,200 tweets if possible. Okay, up to 3,200 tweets. Because apparently that's where, when I did this code, the API limited me. So if an account had more than this amount of tweets in it, then it would be like, this is all you can get. And some accounts have longer than that, like NASA, they'll probably have like 10 tweets a day because they're, promoting their stuff. So like, you can get these numbers pretty quickly when you think about how long Twitter's been around. So that's what I basically just rinse and repeat my requests through a loop until I get this many, or until I run out of tweets to request. So that's why you see the same code here, the 200, but this time I am making sure that I'm getting the next 200 so that I don't like get the same 200 repeatedly. And then append it to my list, and then print some telemetry of what I've been downloading so that I can see if it works. And then once I finish downloading everything, I want to remove the retweets, right? So how do I do that? Well, there's a lot of ways to do that. I keep it plain and simple. If the tweet text contains the word RT, then I assume it's a retweet, and I go in and remove it. So, yep, that may not always work, but it might remove tweets that for some reason have the letter RT in it. But, whatever. It was good enough for what I was doing at the time. Screw it if I cut off some extra tweets in there that shouldn't have been cut off. You get to see this Unicode stuff I'm doing. This is because I wanted to make sure that I wanted to clean up the text because there were some weird characters in here. It wasn't just ASCII, it was like Unicode. And so I wanted to make sure that I cleaned up the text to just be ASCII. Otherwise, like the students had issues because there was weird characters in there that would break the code. So I just wanted to clean up the text. So this was a single one line of code that I could clean it up. How did I find Unicode data? I just Googled and found some Stack Overflow post that said like, this is probably the best way to clean up text. And I was like, sure, why not? One other thing I wanted to do because I was building the CSV files myself was I wanted to get rid of commas to make sure that the CSV didn't break on our CSV parser. So I just replaced it with periods. Sure, I'm changing the original tweet, but I was like, hey, whatever. Again, this is something that I was trying to just get done quickly. So, and it worked, and I'm happy with it. So yeah, that's all I did. And then I'm writing it to a file. Now, I'm only writing particular sections of the tweet that I want. Because again, you saw the JSON, like it has like 100 different fields that I could get from this. I don't want 100 different fields. I just want a couple of them. In fact, I want the one that says the source of the tweet, the actual text of the tweet, when the tweet was created, and then the counts. How many times it's been retweeted, how many times it's been favorited, whether it is a retweet or not, which should be false for all of these because I set it to be false. But back in the day, I wanted to have both. And then a unique ID for each tweet. That's all I really need because all I really cared about was looking at the tweets and how popular they were. And that's it. I do that. So let's go ahead and run the script and see if it still works. I mean, I tested it before when it was working, but let's see it. So you can see that it's running, it's getting the tweets, it's counting down, it's seeing how many tweets it's getting. As you can see, it's getting pretty quickly. And bam, there you go. It got 3,200 basically tweets from NASA. And you can see there, these are the IDs of the tweets that I guess are on the edge of the 20 or the 200 each. And we can go ahead and open up. Oh, by the way, it creates a file with the name of the account as the name of the file. And this is what it looks like. I know it's a little bit tiny. Make sure you're watching always the lectures in HD. Please always like manually select HD. Otherwise, you're going to be like having eye pain by the end of the lectures if you don't watch them in HD. But yeah, so you can see here that it's labeled like source, text, created at, retweet count, and so on. And so here we got the first tweet right there. The second tweet. Let's look for the one that that we saw. Oh yeah, here, the Moonfall film. Yeah, there's the Moonfall film. So let's compare it. So for example, let's look for the one that says aiming to launch in 2029, the Da Vinci. So aiming to launch. Well, which tweet is it? It should be the second tweet actually. It should be. It's really an oddball. Oh, here we go. Aiming to launch. Okay, so aiming to launch in 2029, Da Vinci will taste and smell the Venus atmosphere. So here you go, the same exact tweet as you see here. All the way to the word podcast episodes, which you see there, and then the URL, which is not the same URL you see here, because this is just what it looks like as a URL, but the real URL, as you can see on the, what you would see on the bottom of the page. Hold on, move it this way. Is that one, and that's what you see there. This URL right here. So it's kind of like what Twitter does is they shorten URLs to shorten the length of the tweet by using their own like redirection system. So yeah. But that's what you don't see the Go NASA Gov part. You just see the Twitter one. There's probably one of the fields in the Twitter API, like JSON that you get, that actually has the original Go NASA Gov. So if you wanted to have those and replace them with the Twitter stuff, you'd have to do that extra step, which could be interesting to look at too. But yeah, we're done with it. We got it, and it's all good. So you know, you can decide whose Twitter account you want to look at and stalk, I guess. But this is what the assignment looked like for them. So this was an example of how they got things. This was back, I guess, 2026-8. That's back in the day of that. And in my case, what I wanted to do is I wanted them to format it as this, so that they could see things like a nicer formatting of that. So like text, tweet source, ID, not a retweet, things like that. But also I wanted them to do some really basic analytics, such as what were the top 10 favorite tweets. So they had to, once they got all the tweets, they had to look at all of them, process them, find out the one with the biggest retweet count. So let's look at what that looks like. So in here, the last numbers you see here, 547 and 410, the 547 is the retweet count, and the 4110 is the favorite count. And you'll see that matches this. Well, actually, does it match that? 547 and 411. Well, I see 565. Let's refresh. 586 and 411. So maybe we just have to let's requery it. So we run the program. We get the latest version. And then let's refresh our page here and let's see if they match. Okay, so now it says 547 and it says 4112. That matches this because it says 41K. The retweet does not match, which is interesting. That says 586, but that says 547. I wonder if that's because it's ignoring some of them, or it didn't it's not updated. My estimate, my guess for that is that it's ignoring some which things are not real accounts, maybe. Oh wait, no. Oh, look at that. Okay, so this is wrong. So like when you look here, this is not updated, but when you click on it, you can see it does have 547 retweets, and it has 41113, which we had 41112 because probably there was just one tweet right now. In fact, here, let's refresh it again. So we are right. It's the Twitter website that's wrong on the overall view. When you click on each tweet, you get it. So look at that. If you were web scraping by hand and you were just looking at the timeline, you would get it wrong information. You'd have to manually open each tweet to get it. So look how powerful the API is that you were able to just get it like that. So reload. Yep, here we go, 4113. So now it matches that. Quickly switch to it before somebody likes the tweet and changes it again. But there we go. Okay, you see that? So it is actually correct and accurate, exact. Very powerful stuff. And this is something that you can immediately get the information like that. Okay. So like I said, what I wanted them to do is to look at all of these likes and retweets and basically come up with the top 10 favorite tweets, which at the time was the one that was in 2020, May 31st, with this many retweets, which said, "This is the first time in human history NASA astronauts have entered the space station from a commercial." Oh, this was right after they launched SpaceX's Dragon with people on it, like astronauts. So yeah, big thing. So it was the most retweeted. Be interesting to run this project again and see what the most retweeted one was. And because of that, I would like you all to get a Twitter account and download Twitter, the API, set it up, download TweetBuy, and try to repeat my same project with the same code. You can tweak it to your own liking. And I want you to, while you don't have to do the same thing they did, which is like format the outputs, I would like you to create code to find out what the top 10 favorite tweets are from a given account. So I want you to be able to do that part of this assignment. And these are 135 people. These are freshman computer science students. So I think you guys can do just as good as they can. And find out. And we'll find out if this NASA tweet has been beat in terms of popularity. Or if it's still the most favorite tweet of all time for NASA. But I want you to also do it for other accounts of your liking. Whether it's a person that you like or a company or whatever it might be. Find out the top 10 favorite tweets and also the top 10 retweet counts. Okay. Also, you could find out like the most liked or the least liked. So I have total tweets read. I think least favorite tweet you have here. So you can look at the least favorite one and the top favorite one and the top 10. So go ahead and do that. Moving on, let's move on from this project now. So you got to see a nice example of using the Twitter API, and I want you guys to try it out. But I wanted to show you another example of a little fancier example of what you can do with the Twitter API. And so this one's not something that I kind of really finished. This was something that I did for fun at what was it, like December of 2020 maybe. And this was because GPUs were coming out, the 3080 GPUs, and nobody could buy them because they were really scarce. And so I said, okay, there's a lot of these pre-order bots that you can use to try to automatically buy one of them when they go in stock and be humans that are trying to look for them. And it's a controversial topic, so I mostly did it in the name of science and research. I wasn't trying to sell this to someone to let them pre-order things and become like resellers. Okay, so don't go at me for this. This is strictly in the name of science. Okay, and so what I did was I wanted to again make something that could monitor Amazon, Best Buy, and other pages, and the moment something goes in stock, to automatically order it, so I could get a GPU. And so that was what I wanted to do, but it found out that trying to scan these pages like Amazon and Best Buy to see if there's something else in stock, pretty quickly Amazon catches on that what you're doing, that you're just refreshing the page to find if something is in stock. And pretty soon it'll find out that it's automated, as in it's a bot, and pretty soon it will block you. And so that was a no-go. So I said, okay, yeah, remember that Twitter project that I had? Like, what if I take this a different way? There's some Twitter account on Twitter that actually post when something goes in stock. And why do they do that? Maybe they're just nice to us, but also because they also sell some services to actually buy you these things. So I said, I could link up of that. I could just scan Twitter, and when these tweets come out from these accounts that I've identified as accounts that tell you when something is in stock or not, then I can actually use that information to then check Amazon and see if it really is in stock and then try to do the purchase. Now, if I do 1 or 2 checks for Amazon when I get the heads up from Twitter that something is in stock, I'm not going to get banned. I would get banned on Amazon if I did like 20 checks in a row over the course of a minute. So I said, okay, I can do 1 or 2 checks. I'll be okay. You know, nobody gets hurt in that. So what I did is I took my Twitter code and I modified it to monitor for whenever specific keywords came out that said that some GPU that I wanted was in stock. And so I created the same code that you saw, but in this case to monitor for in-stock items of things that I wanted. So obviously I'm not going to go over too much because all I'm trying to tell you is like an actual practical example using Twitter. But in this case, you can see that this is pretty much the same code as I had before, but I'm doing additional checks and other things and I'm not saying this is clean code. This is against, this is hobby. So I just kind of wrote this and mashed it together and, Legoed it together. And when something broke, I changed it and did things. So it's not the nicest of code out there. But ultimately, I did all this formatting to find some matching keywords which were saved in a list of files. So things like RTX 3090 and EBGA and the brand names. And so when I saw a tweet, that was in stock for this, then I would actually immediately send the command to another part of this bot, which I don't claim to have coded, that could actually make the purchase, which again is another example that I got from somewhere else. And I also had some code to generate JSONs in here too, now that I remember, yeah. I also gave some warnings. I was going to hook this up to my phone to get notifications when something was in stock so I could monitor if the bot had successfully made the purchase or not. I never got around to doing that, so I just did like some text notifications on the screen, and I left the bot running in the background for a couple of days, and it worked. It worked. Great success. And then it stopped working after a while because Amazon updated something and then they broke it. And now even up to today, whenever I log into Amazon, it asks me for my CAPTCHA. Like it forces me to do CAPTCHA. It still thinks I'm a bot. And I contact the customer service and they're like, we don't know what's wrong. And I'm like, I know what's wrong. We all know what's wrong. You just don't know because it was some automated system. But they're like, it's for your safety. I'm like, sure. I actually could get around the CAPTCHAs too. But it was not like the CAPTCHAs stopped me from doing anything. What are CAPTCHAs if you don't know? Let me just Google them for you. CAPTCHAs when you see like text like this, and it's like, please enter these so you know you're human. You also have the things like this where you gotta click on the symbols that are like part of the traffic light or whatever it is. Also, you have like puzzles and things. You know, ultimately, these are pretty easy to beat. Well, not all of them, but a lot of them are pretty easy to beat. So they didn't stop me, but I think that people stop people. They just annoy people, to be honest. But yeah, so not that one, this one. That was fun. That was a fun project, and I just wanted very briefly to just kind of show it up. It's a lot of coding that I did. Frankly, just practice coding. You have to code to keep it fresh. So this was something that entertained me. I used the FurGame bot, which was somebody else's bot, to do the actual purchasing. But then theirs broke, and I had to update it to the latest version to fix it, but that broke mine, so I kind of stopped it. Like I said, it wasn't ever intended to do something more than that. I also wanted to do one for Discord, where like it would monitor Discord posts, but I never got around to doing that. So that would have been another API that I would have to use, the Discord API, which I started looking into it, and it would have worked, but never got around to like doing it. So very cool stuff. You know, I can show more of this at some point if anyone's interested. But for now, I just really wanted to show you an example that the Twitter of how I can do actionable, you know, data from Twitter. So I'm using Twitter to get actionable data on something, in this case, whether something is in stock or not. And then I'm connecting this to another system that is going to actually make an action, which is in this case is purchasing. I could use the same system for stocks. I could use sentiment analysis to monitor like Elon Musk's account, and he posts about Dogecoin and I should just buy Dogecoin or something. I could have done that too. Same system. In fact, it would be very easy to modify the code to do that for that. I don't know if that's a very smart financial decision to do, but all I'm saying is that it's just an example, a real example of something that you can actually do with the knowledge that you have, and you know, it's cool. It's just cool. It's cool. Like you're actually developing something that now can process information, do data analytics on that, and make a decision, and then go and move forward with that decision. Okay, so that's one example of a project with Twitter. Now, moving on to a completely different project, I want to show you blockchains. So, you know, blockchains, everybody's talking about blockchains these days. It kind of comes and goes over the years. And there's, of course, some of the more famous ones. That would be Bitcoin and Ethereum and all the other ones. So in this case, I said, okay, I would like to make a monitoring system that can either monitor the Bitcoin price on the go, or it can just download all the Bitcoin data so that I can then perform some data analytics on that data, machine learning, whatever you name it. Okay. In fact, the reason why I was doing it for this project, which is still a work in progress, but then again, I kind of lost inspiration on it, so it's work in progress. But I'll finish it someday and write a paper. It's because I wanted to make a graphical interface for displaying the transactions. So for blockchain, very quickly, how blockchain works is you build blocks on top of each other, and each of these blocks contains transaction information, and that transaction information is going to basically be a transaction that shows a from and a to address, and the amount, and a couple of other details. Okay, and there's basically like 100 of these in each of these blocks, and the previous block contains a hash to the block before it, so that it knows that it's the next thing and it makes it safe, etc., etc. Okay, very cool. But what I wanted to do is I wanted to be able to take all this blockchain information and actually make a graph showing transactions, with the purpose of trying to find illicit transactions. So like, let's say that person 1 sent money to person B, okay? So what that would look like would be person 1 here sending money to person B, okay? And then person 2, or person, I said 1 and B, let's just say letters, A and B, okay? So person B then sent money to person C and D, and person C sent money to persons E and F, okay? Person A also sent money to person X. Here's where shady things can happen. let's say person B sent money to person T. Person T sent money to person G. Person G sent money to person A. Okay? There's a cycle here. Why would there be a cycle? Well, there could be transactions that just happen to end up being a cycle, but there could also be some potentially money laundering. Like I could be trying to do this to kind of hide where money is going, right? Like I could, if I'm trying to send money from A to B, but I send it to like 50,000 different accounts all over the place to connect there, maybe all of this is just showmanship to hide the fact that this was going there, right? And the more connections I make, the more sort of hidden it is. But this stuff is not hidden in blockchain. You can very easily find this. Anybody with a little bit of technical knowledge and web scraping and APIs can find out where money is going in blockchains like Bitcoin. So the problem is the non-technical people, or even the technical people, might not be as easy to see these sort of cycles or connections unless you have a graphical interface where you can actually see a pretty graph and you can actually see the circles going, and they can be highlighted by when there's a circle, like imagine it's like you see a highlight and now you actually see the circle and you're like, oh yeah, there is a cycle there. Let me go investigate on that further. Like I'm working for the IRS or something. And so that's what I was trying to do, right? I wanted to be able to do this graphical interface, and I got as far as actually graphing it, but I still got to write the actual publication paper, and I'm working with a master's student, PhD student who is who is not his main thing. It's kind of like a side project, and I said, hey, can you help me make the graphical interface nicer? So he was doing a little bit of that, and so it's just kind of thing we're doing on the side, right? Just for fun. We're not trying to make NTS or random profits. This is like strictly a free thing we're doing, okay? So ultimately, we need to get the blockchain data. Now, the real way I want to do this eventually is you can actually download the entire blockchain by creating your own node and then processing the data there. But until that's like literally the last thing I want to do. Until I get there, it would be just nicer to get from a website that can provide me the information I want from each transaction within the limited amount, just so that I can actually start experimenting on these things. And then once I'm ready to go, then I can actually download the entire Bitcoin blockchain history and run it from that. And so I found the website blockchain.com, which actually provides just that, and through an API. Normally, if you go to blockchain.com, you can go to what's known as the Blockchain Explorer. You can look at each block and you can see what kind of transactions happen, which are here. So for example, you see there's a transaction from this one. So click on this to see this transaction, and it tells me that this address, which is an account, a wallet, sent 75 Bitcoin to these two wallets. Oh yeah, that's right. It's because the way the way blockchain for Bitcoin works is you send the full amount out of the wallet to another wallet or to yourself, and then a little bit to another wallet, which is what you're actually transferring. So that probably might be happening here, or they could have just hardcore transferred 75 Bitcoin, which would be at today's value, we are talking about 40,000 times 75, so close to somewhere like $3 million. Okay, so yeah, it's a lot of money. So yeah, okay. Anyways, the point is you can see all this information, and it's pretty nice to see it. Obviously, that's kind of crazy. It's probably because it's sending it to itself. That's what's happening. Yeah, this is more like legit what a transfer was, because 0.05 of BTC, that's more like what us normal people would be transferring, which is 0.05. Well, it's still at $1,800, but still, that's not like $3 million, right? So yeah, so there's that transaction happening. Okay, I want to be able to get this information into Python so that I can do my graphing. And so it turns out that blockchain.com has an API, and unlike the Twitter API, this one is a free API. It's still very limited, like hardcore. Like they'll let you do like, I think it's like 2 or 3 requests per minute, and if you do more, you get blocked for like 10 hours, which is really annoying actually. But you know, just for basic testing, it's good enough. And so the way that you make the request here is actually pretty neat. It's just literally you build the HTTP address that you want and you get a JSON back. So for example, suppose that I want to do a request for this block right here, block 154595. All I gotta do is create the URL that is going to generate that request. So that is going to be number of the block. And as you can see here from the API documentation, all I gotta do is write this URL. And then instead of putting the block hash as a $sign, I literally just put the actual hash. Actually, the hash is going to be not that block number, but it's going to be this hash number here. So I'm going to put that there. So I generate that link. I enter it. And I get back the JSON. So I enter in my URL, as you can see. And I get back the JSON file. And this is the JSON file that I would otherwise download and process. It's pretty cool. And it has the same information. So like, for example, here we got a transaction. Here are the inputs and outputs. So like, for example, here's the transaction hash. Where's the address? Well, this is a block, so it just has addresses like this. But here, let's look at an actual transaction request. Single transaction. So like, let's go ahead and do this request right here. So copy this, paste it here, copy this address of a hash, paste it there. And now this one, you can see the input is this address, how much money is being sent, which is going to be this is the address is being sent to, and then the value of that is going to be, it's been a while since I looked at this. It's easier to see here. Value, I guess it's value. The value is going to tell you how much is being sent. Just these numbers look ridiculously big. I think it's in Satoshis, that's why. Yeah, Satoshis. Satoshis is like 1/1,000,000th of a Bitcoin, I think, if I recall correctly. It might be even smaller than that. So that's why the numbers look so big, because they're in millions. That's like, it's like, imagine you were writing something in pennies. You're like, this thing is worth 100 pennies. Okay, that's like just $1, right? Well, okay, pennies because it's nice, but like, imagine now there's things smaller than pennies, like millionth of $1, and that's what Satoshis would be. Okay, so yeah, you can get from here all the information about the addresses you're sending and the amount. And how to generate it is you just need to find out which transaction you're looking for and generate the URL, and you get back the JSON, which you can then download. You can do that for other kinds. You can explore this on your own time. It's just blockchain.com.api. But like I said, you can do this right now at home. There is no login credentials. And so why did I do with that? Like I said, I did the cryptographing thing, and here's just an example of what that looks like. So I have here I try to organize the code well. So I have a function called common, which has some functions that actually do the API request. So for example, here, let me show you a request here. So here's my request. So I'm going to create the URL by doing http blockchain.info request type and string. Why do I do it like that? Because if you notice, all the URLs that do the request start with blockchain info, and then this is the type of request. So a single transaction is called raw TX, single block is called raw block, chart data, I don't ever use that, but it's called charts, I guess. Single address, I did use that one, it's called raw address, raw ADR. So as long as you put all of those, then you know which kind of request you're doing, and then it's followed by either the transaction hash, the block hash, or in the case of the address, it's just the address, I believe. Where's the address at? Skipped it. Bitcoin address, right? And so in my case, it's just called request value. So I formulate the URL that I need, and then I use I think this is like not even like, I'm not using any code related to blockchain. I'm just using a generic API requester, which is called urllib request import URL open. Yeah, URL open is the name of this library, I think. And that's the one that I use because you can just send URLs that way and get back data. So it's just some generic thing. If you want to know more about URL open, you can just Google it and find out. Python examples of URL request URL open. So here you go. You can just go look at examples randomly online and read more about it. I guess the library is called urllib. urllib3. urllib is a powerful, user-friendly HTTP client for Python. urllib brings many things, thread safety, etc., etc. So yeah, here's how to install it. Python pip install urllib3. So ultimately, this is a way to send HTTP requests. And if you remember from the samples here, is one of the things that you do for web scraping, right? HTTP requests, and you get back JSONs, which is what we got back. So that library is very flexible because it allows me to do requests for not just the blockchain thing, but anything that I need to just do an HTTP request with and get back a JSON. And so that's basically what I do back. I get a response from the API with the JSON file, which then I go ahead and actually create a JSON object in Python to load the data in and save it. And that's what I return back. For that, I import JSON. So that's a JSON library that I was saying, like some time ago. And so that's what I do. And now I can process it and feed it to wherever I want and generate my graphs. And they look really cool. Like, I wish I had a picture of the graphs to show you really quickly. Let me see if I can find one very fast. They look really scary though, because they're really big, obviously, when you have all these transactions. Because think about it, one account can send like other accounts money. Like think about how quickly money spreads when you pay money, right? So this is what it looks like when it's a simple thing. You can see just a nice little address, just a test address. Yeah, account 1 sends to account 2 to account C and whatnot. So that's like, hey, happiness. And then this is when you're like, oh boy, this is, I'm going to need a better system for displaying all the transactions. And that's why this is kind of work in progress. It almost looks like it's alive. Those are the transactions. So that's no good. As you can see there, that's like, oof, that's not cool. You get like billion. It's impossible to read that. Now it's the whole point of this is to make it easy to see your transactions. But when you got that many transactions, there has to be a better way of displaying them and filtering them. So that's where I'm at on that. I want to show you one more picture of some of the graphs and what they look like. So this is an account where you have right here, this one is basically a single address that's sending to another address, but that other address is very popular and it's probably like from one of the exchanges, and it's communicating to a lot of addresses. So yeah, it's like single one goes to one that has like a massive amount. So you got to deal with that. And this was also searching for present to for the last I don't know 2 weeks of transactions. So I could also limit it to make it a smaller transaction list, or to a time period as well. So yeah, okay. So anyways, I wanted just to show you some examples of using APIs, primarily the Twitter one, but also wanted to show you an example of a public one with the blockchain one, and in general, just give you an overview of some APIs. So that's all I have for today. I thank you all for watching, and we shall continue next time. I'm not 100% sure what I'll do for the next video. It'll be on web scraping, but I'm gonna try to do something a little bit more on when you don't have an API, which is like the real hard web scraping. But that can get pretty tricky, so I'm only gonna go to a certain depth with that. So I'll explore some examples, maybe use something with Beautify Soup or Selenium or something, and ultimately I'll try to come up with a video that's not too weird, too complex, but practical data. Usually you will be working with APIs. Because of all the legality stuff we talked about, APIs is the best way to do it, because if you're using an API, then you know it's okay to use it. Otherwise, they wouldn't exist. And you have limitations on rates and things like that, which are meant to make sure that you're on the good side of the law. And so that's where most of your requests should be coming in. But sometimes, websites don't have APIs, and that's when you have to find other ways. And that's what I'll try to cover next time. So with that, I will close out this video. It's been a recordable lecture on the go, so it's tiresome. So I'm hoping that I had enough energy to show you this. And of course, if you have any questions, don't hesitate to reach out to me. Thank you for watching, and take care.